Hi guys! Today you're watching a video lesson. I have not done this for a little bit, so I hope that it works okay, and I will do the best I can to make it into one video, but it might have to be split into parts, but we'll just wait and see how it goes at the end. So, today we're going to be talking about complex numbers. It's section 1.4. I think I mentioned this before I left, that when you're watching the video and taking the notes, just like we would do normally if we were in class, you can always pause the video if you need a minute to write stuff down, because I've pre-written a lot of the stuff just so the video part goes faster, and then you can pause it as you need to. So let's get started. Let me see here. Let's see. There we go. So this is section 1.4. Let's see. I don't know. Maybe it's not going to work. Okay, on complex numbers. So there came a problem in mathematics. How can we solve something like x squared plus 1 equals 0? I have to go to the other side. And if we thought about trying to subtract 1 on both sides, we would have x squared equals negative 1. And mathematicians knew at this early time in mathematics that, hey, we can take the square root of both sides, but we didn't have any notation or anything for the square root of negative 1. So mathematicians didn't know what was happening, so our understanding of numbers had to change. So that's where we get the imaginary unit I. It's defined as I being the square root of negative 1, and thus then I squared is equal to negative 1. So if we look at an example of trying to simplify a square root of a negative number, we would have the square root of negative 25, which is the square root of negative 1 times 25, which we know from our properties of square roots is the square root of negative 1 times the square root of 25. But we now know that the square root of negative 1 is I, the square root of 25 is 5, and in the same way that we deal with variables, we would not call this I5, we would say 5I. Okay? So then we expanded our number system now to include the imaginary numbers. So they're called complex numbers. So I'm going to slide this down, maybe, I think. Okay, yes. So complex numbers had to be this new number or new system of numbers to accommodate the imaginary unit. And you might remember that this is what we drew, oh gosh, pretty close to the first day of school, where we were talking about all the numbers. And now we can draw another box around it. Okay, something like this, where we have all the real numbers, which again are split into really rational, irrational, and then the rational numbers are split up into other ones. And then we have, oh gosh, I can't draw on this paper. Over here, we now have imaginary. And this entire system are called complex numbers. And the symbol that we use to notate complex numbers is C, but it has like the extra little line on the side, on the inside. So that is how we show complex numbers. It just occurred to me that I'm not sure about a symbol for imaginary numbers. I was going to look it up really quickly. We don't use that very often. No, there really isn't one. So we don't really have a fancy letter symbol for imaginary numbers that I can see. Okay. All right. Couple of things about the complex numbers. The set of all numbers in the form a plus bi, with real numbers a and b, and I, the imaginary unit, is called the set of complex numbers. And there's our little symbol again. The real number A is called the real part, and the real number B is called the imaginary part of the complex number. So when we look at some different complex numbers here, kind of just determining the real and imaginary parts of them. If I look at this complex number, 4 plus 2i, the real part of that is 4. The imaginary part is 2. Notice that it's just 2, not 2i. The imaginary part would indicate then, of course, that this number is followed by an I, right? And when we have a plus bi as our standard form, b is the imaginary part. Okay, so just the number value, not the I. So in number 2, we have 6 minus 5i. The real part there is 6. Be careful here, the imaginary part is negative 5. And on the third example, negative 11 plus I, the real part would be negative 11. That's a real number. And the imaginary part here, be careful even though it's not written there, is 1. Okay? A complex number is said to be simplified if it is expressed in standard form, a plus bi. A quick note, here we go. Imaginary parts that include radicals will be written with the radical at the end. So we would write this and we would say it as 3 plus 2i square roots of 5. We would not say 3 plus 2 square roots of 5i. Again, in the way we read it, it makes a difference because then we're not sure if that I is under the radical, but also if people get sloppy with their writing, we don't want to have any question as to what's under the radical. However, when you're looking at a complex number that includes a radical in the imaginary part, keep in mind the real part here is 3. The imaginary part is 2 square roots of 5. So this whole number that we have in here, excluding the I, is the imaginary part. Okay, moving right along. Now we're going to talk about operations with complex numbers. Oh, look at the sun weirdly shining in on that. I think it's okay. So we're going to talk first about adding and subtracting, which is really just combining like terms. Here's some examples. Perform the indicated operation, write the answer in standard form. So when we are adding two complex numbers, a lot of times complex numbers will be written in parentheses like this. We don't really need the parentheses in this case, so we can get rid of them. And then we're looking at combining like terms. And I sort of acts like a variable in this case, so we need to think about 5 plus 7, which is 12, and then negative 11i plus 4i, which is negative 7i. And that's our final answer on that one. That is written in standard form. The real part is 12. The imaginary part is negative 7. Okay. On the second one, though, we are subtracting complex numbers, and in the same way when we're dealing with regular polynomial or other things with variables that we're dealing with subtraction in front of these parentheses, we need to distribute that negative first so that we have plus 11, and in this case, plus 6i. Now we look for our like terms, negative 5 plus 11, that's 6. I plus 6i is 7i. And we're done with that one. The real part is 6. The imaginary part is 7. Next we move to multiplying. Okay. Similar to multiplying polynomials, we're going to use the distributive property. The only other kind of different thing on multiplying is that after you multiply, you must replace any I squareds with a negative 1 and then simplify. One of the nice things is, and we haven't really talked about this property yet, but even with addition, subtraction, and also multiplication, when you multiply two complex numbers, the answer is a complex number. We will never end up with something that's now suddenly not a number, just like if we multiply two real numbers, the answer is a real number. So that's why we can't ever leave I squared in an answer. We always have to replace it with negative 1. So on our first example here, 7a times 2 minus 9i, we'll distribute 7i times 2, that's 14i, and 7i times negative 9i is negative 63i squared, but I squared can be replaced with negative 1. Oh, I hope that didn't, okay, I don't know. Negative 63 times negative 1 is positive 63, but this is not written in standard form. We would write that as 63 plus 14i. I'm going to check on this video, so I'm going to pause it here and then come back. We'll see what happens. Okay, the second example is multiplying two complex numbers, 5 plus 4i times 6 minus 7i. So again, we're going to distribute here. So 5 times 6, that's 30. 5 times negative 7i is negative 35i. 4i times 6 is 24i. And 4i times negative 7i is negative 28i squared. Then we do a little bit of simplifying here. We have 30, negative 35i plus 24i is negative 11i. And then we have minus 28, and we change our I squared into negative 1. So then we really have 30 plus 28, because negative 28 times negative 1 would be positive 28. So we have 58 minus 11i. And our last example on multiplying is multiplying, again, we'll distribute, so 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is positive 12i. And 4i times negative 4i is negative 16i squared. This one has an interesting little thing. You can notice that we have minus 12i plus 12i. Those cancel. I'm left with 9 minus 16 times negative 1. But 9 minus, that's silly, 16 times negative 1, or 9 minus negative 16 is 9 plus 16, or 25. But notice that this says write the answer in standard form. So we're going to write that as 25 plus 0i. And that's how we'll write our answer always in standard form. Okay. So that one turned out to be sort of interesting. In fact, what we'll find, is up here at the top. A plus bi and a minus bi are called complex conjugates. We've talked a lot about conjugates, multiplying conjugates, factoring the difference of squares into conjugates. When we have a plus bi and a minus bi, they're called complex conjugates. And what we're going to know is that every time we multiply complex conjugates, the answer is going to be a real number. Sort of like back here. Maybe if I can, I'm not going to be able to do it well. Right? Where really 25 is just a real number when we multiply these complex conjugates, 3 plus 4i and 3 minus 4i. Those are conjugates. Okay? Now, we need to know something about complex conjugates, because in order for us to divide imaginary numbers or complex numbers, we're going to multiply the numerator and denominator by the complex conjugate of the denominator. That's because when we're dividing complex conjugates, consider for a moment that when we have I in the denominator, that's really like having a negative, or not a negative, a radical in the denominator, and we don't like to have that. So in order to divide, we're going to multiply by the complex conjugate of the denominator. This denominator on the first one is 2 minus 5i. So I'm going to be multiplying by 2 plus 5i over 2 plus 5i. And in this case, we're going to have to do a lot of distributing, which is okay. I'll distribute on the top. 7 times 2, that's 14. 7 times 5i is 35i. 4i times 2 is 8i. And 4i times 5i is 20i squared. Over, and then interestingly, and you're going to kind of find this, and so you'll kind of just know it from the get-go now, 2 times 2 is 4. If we look at this, we would get plus 10i minus 10i. Plus 10i, I'll write it on this one, maybe not on the next one. And then negative 5i times 5i is negative 25i squared. Now, when we simplify in the numerator, we're going to have 14. 35i plus 8i is 43i. 20i squared is really 20 times negative 1 or negative 20, we'll say. In the denominator, I have 4. The plus 10i minus 10i reduce or cancel. They cancel. And we have negative 25 times negative 1, which is positive 25. I guess we'll go here. So now I just combine the like terms on top. 14 minus 20 is negative 6 plus 43i. The denominator, 4 plus 25 is 29. But this is not written in standard form. In order for it to be written in standard form, we need a plus bi. And we don't have that right now. So we need to split up this fraction. And it would look like this. So that we can now clearly see the real part of this complex number is negative 6 over 29. The imaginary part of this complex number is 43 over 29. And this is how we would write our answer in standard form. Okay. On the second example, the denominator is 4 minus I, so I'm going to multiply by 4 plus I over 4 plus I. And when I multiply, or when I distribute, in the numerator, I'll get 20. 5 times I is 5i. 4i times 4 is 16i. 4i times I is 4i squared. Over. In the denominator, now we're going to just kind of know what's happening. 4 times 4 is 16. We would get plus 4i minus 4i. Okay, so that's 0. Negative I times I is negative I squared. And then again, we do some simplifying. This is 20 plus 21i. This would be now 4 times negative 1 or negative 4 over 16 minus negative 1. 16 minus negative 1 is 17. So I'm going to have 20 minus 4, which is 6 over 17, plus 21 over 17i. Okay. All right, so take a minute to kind of think about those. Maybe try that on your own and make sure you're understanding. Okay. All right, last topic we really need to talk about in this section are square roots of negative numbers. This can be kind of a big deal or kind of a problem if you're not careful. The square root of negative b, or the opposite of b, is I square roots of b. And what we know is that the square root of that negative must be simplified before any other operations. And so I'm going to show you how it matters which order we do them in. On this side, we've got the same problem twice. Okay, I'm going to do it correctly here. So we're going to first simplify this as, I square roots of 25. The square root of negative 4 would be I square roots of 4. Well, the square root of 25 is 5. The square root of 4 is 4. When I multiply, remember we can multiply in any order we want. So you guys, this is not 4, this is 2. Oof, sorry, it's been a long day. All right, that's 2. This would be then 10i squared but I squared is negative 1. I hope you can see still, yes, and that makes the answer negative 10. Okay, now, if we didn't do it correctly and we said, oh, I know, when I have two radicals, I can put them together under a single radical. If I did negative 25 times negative 4, I would get positive 100, and the square root of 100 would be 10. And I might think that my answer is positive 10, but it is not. So we're going to draw a big circle around this with a no. Okay, we cannot do it that way. The I has to come out first before you can do any other operations. Okay. All right. So just a couple of examples. Hopefully. Okay. So we're going to, again, perform the indicated operation, write the answer in standard form. When I look at the square root of negative 18, I need to rewrite that first as I square roots of 18 minus I square roots of 8. But the square root of 18 is really 9 times 2. The square root of 8 is 4 times 2.
Honey.
What?
You know where my shoes are?
I don't know. I'm doing the lesson.
What are those?
You're silly. Sorry. Oh, where was I? Totally lost my train of thought. Are you leaving? Yeah. Okay. We have the square root of 9, which is 3, so this is 3i square roots of 2. This is now 2i square roots of 2. 3i square roots of 2 minus 2i square roots of 2 would be 1i square root of 2. Oh, that's bad. Why is that bad? We didn't write it in standard form. We would have to write that as 0 plus I square roots of 2. There's our final answer. Okay, don't forget standard form. Okay, lastly, oh, geez, okay. Okay, last example. Now we're squaring the complex number negative 1 plus the square root of negative 5. Before I can do anything, I need to, again, reduce or simplify the square root of negative 5 and call that I square roots of 5. Now, we're going to use the same process that we used for squaring a binomial to square this complex number. Square the first term. I might even just write it out here. Plus 2 times the first thing times the second. So 2 times negative 1 times I square roots of 5. And then square I square roots of 5. When I square negative 1, we get positive 1. 2 times negative 1 times I square roots of 5 is negative 2I square roots of 5. When I square I square roots of 5, remember this is like I times the square root of 5. So I have to square the I, which is I squared, and square the square root of 5. When I square the square root of 5, it's 5. So now I have 1 minus 2I square roots of 5 plus negative 1 times 5, or 1 minus 2I square roots of 5 minus 5, which is negative 4 minus 2I square roots of 5. That would be our final answer on that one. Okay, and again, if you want, you can write that out and square it. Either way is fine, as long as you get the right answer. Okay, so your assignment is posted on Canvas, and I left copies of the page for you to have passed out. It is section 1.4. It's on page 146. You will do numbers 2 through 44 even. Oh, and also you have that. And also you have a section 1.2 homework quiz. Okay, so today you're watching this on Tuesday. So the homework quiz is due Thursday morning. Okay, due Thursday a.m. The section 1.4 is also due on Thursday by class time. Oh, let's see. There we go. So make sure that you get that all done. Take care of business. Have a great day, and I will see you guys on Thursday.